Okay, so what we're going to do is create the sine curve. We're going to create the sine curve. So the sine curve comes from the unit circle. The sine curve are the y values. The sine curve is the y value. So what I'm going to do is this. These are my angles, okay? These are my angles, so we can call this theta, okay? And my angles are going to go pi halves, pi, 3 pi halves, 2 pi. So that's going around the circle, right? I'm going to add some just because it's going to make it a little bit better for me if I add some. So the ones I want to add pi fourths. I want to add 3 pi fourths. I'm going to add 5 pi fourths and 7 pi fourths. And Ben, I could add 9 pi fourths if I wanted to, and that was the one that was on your that we scribbled out, okay? So I just did all the fourths, is what I did. I put in the pi fourths, so it goes 0, pi fourths, pi halves. Then I did 3 pi fourths, pi, then I went to 5 pi fourths, then the 3 pi halves, then the 7 pi fourths. So I just added in the fourths, Makaiwa. So pi fourths, 3 pi fourths. So these are all the important angles going around the circle. Does that make sense? So let's get the values. So what we just did in our chart was we know that, let's go first to 0. At 0 radians, right here, what's the y value?
0.
0. So we're going to have a dot or a point at 0, 0. Okay? At pi fourths, we have square root of 2 over 2. It's approximately 0.7. Okay? If you use a calculator, square root of 2 over 2 is about 0.7. So I'm going to go at my angle, the height is about 0.7. Pi halves, we said the y value of pi halves was 1. 3 pi fourths, square root of 2 over 2, but we said that's about 0.7, right? So we did about 0.7. So I'm going to estimate 0.7 to be right about there. How am I doing? Am I going too fast or okay?
Great, Mr. Babies. We're doing
Okay, at pi, we said the y value, pi was 0, right? At 5 pi fourths, it's a negative square root of 2 over 2, which we said is about 0.7, so it's a negative 0.7. So I'll estimate negative 0.7 to be right about there. 3 pi halves, we said the y value is negative 1.
Mr. Babies, where is this applicable in real life?
Everywhere.
Everywhere, Ben.
Everywhere.
Wait, hold on.
Everywhere.
Yeah, slow down.
Okay, your cell phone for one, okay? Every time you send a text to somebody that travels,
But like, will I ever use this?
every time you use your cell phone, yes.
Yeah, you use it. How are you going to be able to use your cell phone without understanding the natural complexities of sine waves and how they're transmitted?
Right.
You ever think about that? No. You don't think about your
3
cell
pi halves is at negative 1,
Okay.
right?
Yep.
7 pi fourths is negative 0.7, right? And then 2 pi is back to 0. So what we're going to do, Ben, you watching? Is we're going to go ahead and trace in what we call a sine wave, okay? So sound will travel in this pattern. Ocean waves, right? Any wave. Drop a rock into a pond, it's going to go ahead and travel in a wave, right? This is one wave. So the height of the wave has a height of 1, right? So its amplitude is equal to 1, because that's the height. It goes up to 1 and then back down to negative 1. That's the amplitude. And its width, which is called its period, its width goes from 0 to 2 pi. Its width is 2 pi. One full curve is 2 pi. That's its period, okay? All right, not too bad. Now, we know it keeps going on and on and on, but the pattern will repeat itself. Does that make sense? So we're going to talk about just one. So I'm going to highlight that. This is my one standard sine curve. That's my sine curve right there, okay? What we're going to do with this is we're going to modify it. We're going to change the sine curve so we can use it and show Ben where the applications are, okay? Now, if I take a look and I shift this over to your cosine values, okay? And again, I need to add my force. So I need to add my pi force here. I need to add my 3 pi force here. I need to add my 5 pi force here. And I'll add my 7 pi force here, okay? So I've got all of my angles from the circle, but I just added the force this time, okay? So I added my pi force, my 3 pi force, 5 pi force, 7 pi force. And those are the values, those are the angles on our circle, okay? So your cosine values, right? And you guys filled this out. I think you got probably square root of 2 over 2. You probably got a 0, right? You got a negative square root of 2 over 2, right? You probably got a negative 1. You probably got a negative square root of 2 over 2, right? You probably got another 0. You got a positive square root of 2 over 2. And you've got another 1, okay? Those are the cosine values, right? So watch. At 0, at this angle, at 0. Okay, at 0, what's your x value?
0.
1.
1, right? So this one starts up here at 0. We get a value at 0, 1. Guys, you watching? Okay. Now let's go ahead. Pi force was square root of 2 over 2, which is about 0.7, right? Pi halves for the cosine value is 0. 3 pi force is negative square root of 2 over 2, but we know that's about negative 0.7, so I'll estimate it to be about there. Pi is negative 1, so I'll have a value there. 5 pi force is negative square root of 2 over 2, which is about negative 0.7. It's about there. 3 pi halves is 0. 7 pi force is square root of 2 over 2, that's about 0.7. And then at 2 pi, we're at back up to 1. So one cosine curve looks like this. Almost identical to the sine, except for it starts in a different place. You see that? So the two curves are very similar. The difference is where they start. Okay, so the applications between the two, real quickly, so you guys can see the applications. Okay, so the sine curve is if you were to drop a rock into the water, and then the curve starts. That makes sense? Starts at 0. This one, an application, this could be like a spring. You've got a spring already up, and then you let it go, and it bounces, right? And it's going to bounce up and down, up and down, up and down.
Still applies to a wave because when you first drop it in, all the water goes through it.
Yes, yes, it does, absolutely. So you're totally right, Cody. But at time equals 0, it's at 0. Does that make sense? And then it's going to go, right? Very good. Okay, so these are the two main curves. What are we going to do with these curves? We're going to make them taller. We're going to make them shorter. We're going to make them skinnier. So listen real carefully, and I'll try and say this the best I can. You listen?
Yep.
When I talk really quietly, you have a very small amplitude. If I talk really loud, we have a really big amplitude. Now think about this. Back in the old days, you'd turn up the amp, and the volume would go up. So as these waves go bigger, you get a bigger sound. Or if you throw a bigger rock, you get a bigger wave. It changes the amplitude, and the height of the wave gets bigger. If you want to change the frequency, okay, so if you talk really high with a high voice, you get shorter waves. Does that make sense? If you talk with a really low voice, you get really long waves. What we want to do is change the length of the wave, so we're going to change the period. Cody, question?
Well, could you just say you're amplifying it by making it all?
Absolutely, and these are all science terms, aren't they? Total science terms. So what I'm really doing is helping Mr. Massey out when you take physics, right? Because this is what you're going to do in physics, is this kind of stuff. Okay, so I'm going to 8.4. I want to look at these graphs. So here it is. Number 1, I'm going to take my sine graph. I'm going to take this graph right here. See my sine graph? And what I'm going to do with my sine graph is I'm going to make it 3 times as tall. So the amplitude is equal to 3. So I'm going to go 1, 2, 3. So my graph's going to go up to 3, and it's going to go down to 1, 2, negative 3. Okay, my amplitude, we're going to make it 3 times as tall. My amplitude changes. We're also going to make it so that we get 2 curves. We're going to get 2 curves in the shape of 1. So it's frequency. It's another science word. So it's frequency is equal to 2. Now, if I'm going to get 2 curves, if I got to fit 2 curves in here, I've got to make them half as wide, right? So I'd have 1, 2 curves. That makes sense? So I'm going to take my normal period of 2 pi, and I got to divide that up into 2 parts. so that each curve will be a width of pi, and then I'll have another the width of pi, and that way I'll get two of them. I'll say it again. I'm going to take my sine curve, I'm going to divide it into two parts. It'd have to be pi a piece, so I'd have to get one width in here, and I'll get the second one in here. So it's just going to be skinnier, skinnier. So when I do that, again, I like to go every 4. 1, 2, 3, 4 squares. You'll see why. Let's go pi fourths. I'm sorry, pi halves, my bad, pi halves. 1, 2, 3, 4, let's go pi. 1, 2, 3, 4, let's go 3 pi halves. 1, 2, 3, 4, let's go 2 pi, okay? I need to get the angles down. So my graph is ready. I've got my axes labeled. Let's do it. Let's take this shape. Let's make it go up to 3, down to -3. Let's take this shape and get one curve, two curves, okay? I'm going to do it like this. Let's see if I can do this slowly so you can see it. It's going to look like this. Okay, there's one curve. There's one curve from 3 to -3. I need two curves though, don't I? I need two curves, so I'm going to do the second curve. Now you see why I use the 4 squares, I think. You'll see why. Because it's 4 parts to the graph, right? And there it is. That's my 3 sine of 2x. It goes up to a height of 3, down to -3, and there's 1, 2 curves within its normal width. There is 1, 2 curves within its normal width. A height of 3 or an amplitude of 3. Its new period is pi. Its new period is pi because its width is pi. So we get 2 curves, 1, 2, okay? All right, now let's take a look. Am I going too fast? Okay, let's look at the next one, cosine. So I want to take this curve, right? And what I want to do with this curve is I want to make it go to a height of 4. So it's going to start way up at 4 and go down to -4 and back up to 4, right? But I need two of these curves within this, okay? So I know the amplitude is going to be 4. Height of 4, down to 4. The new period, its new width, is going to be 2 pi divided by 2. So I can get 2 of them in there, okay? It's going to be always 2 pi because that's the standard period. So I take my 2 pi, which is the normal width, and I divide it up into 2 parts, right? So the new period, new period is pi. So I'll have 1, 2 of these. It's going to go from 4 down to -4, okay? Now I'm going to do this in just a moment, okay? So you're ready. So my curve's going to look like this. Let me put in my 1, 2, 3, 4, -1, -2, -3, -4, because I need to go from 4 to -4, right? I'm going to go every 4 squares. I'll go pi halves, pi. I'm going to go 3 pi halves and 2 pi, okay? All right, here's how it's going to look. And I'll try and go slowly so you can see it. Okay, it's going to look like this, boom, boom, boom. Okay, there's one cosine curve. Oop, missed that one. There's one cosine curve, right? And it's between 0 and pi, because if I'm going to get both in, they've got to be pi wide. And the second one would look like this. Okay. So let's see what we have. I have a cosine curve. So if I look at my normal notes, that's what a cosine curve looks like, right? I have gone up from 4 to -4, and I have 1, 2 curves within its normal width. Thumbs up? Okay. Let me stop recording, and then I'll work with you on the homework, okay?